Anybody questions from homework?
I was wondering if you could go over the first one from section 1.5.
Let me see. Let me find it. Here we go.
Yeah, it was like the ordering pair.
Yeah. So we did do a few of these together. What are you having trouble with these right here?
Yes.
All right. So it says use hours after midnight for the first coordinate. Right?
And then the temperature is the second one. Okay, never mind. I got it now.
Oh, okay. Okay.
Sometimes it takes like 5 minutes for some things to come back to me.
I understand. And then, of course, the difference between number 2 and number 7 is that number 7, they want you to start at 50 degrees here.
Okay.
And number 2, they want you to start at 0. Whoa.
Okay.
So it's going to be the same data, just one of them is going to be smushed and the other one's going to be stretched out.
Good thing I got some graph paper.
All right.
Thank you.
Cute. All right, guys, some more people have joined. Yay, let me see how many I'm still missing. I'm only missing 15 now. All right, I'm well past the halfway point. Is that a good thing nowadays? I don't know. I don't know anymore. Anybody else questions? All right, so I definitely need to go back to 1.4. There are many issues with 1.4. So let me do this. Let me turn off my cool background. Bam. And then we'll go up to the board. All right, so, well, man, doesn't want to come off. All right, guys. I really desperately want you guys to get this. So let's focus on this a little bit. This is a pretty cool shortcut that we learned in section 1.4. And I really want to make sure everybody understands it. So let's do this 2 ways. Let's do this long way and then the shortcut. So let's say something costs, oh my God, Jeff, this poor little marker. Something costs $1,000, right? And we're gonna increase that by, let's say 40%, but we're gonna do it 3 times. Okay. Let me stop for a minute. Is everybody with me? So I want to apply a 40% increase 3 times. What that means is a 40% increase and then another 40% increase on top of that. Okay, stay with me. I'm trying to get some new markers here. Come here. Gotcha. So the first increase, how do I figure out how much it goes up to? So it's currently $1,000 and I want to increase it by 40%.
We have to find out what 40% of 1,000
Yes.
is, right?
I have to do 40% of 1,000. How do I do that? What's 40% as a number?
0.40.
Is that cool, everybody? To always change from percent to decimal, you move the decimal back once, twice. And what does of mean?
Times.
times. So what's 0.4 times 1,000?
$400.
400.
Yeah.
So what's the new price?
$1,400.
All right, now we're going to increase by 40% again. We're going to do it 3 times. Shit. So how do I increase that by 40%? I would take 40% of 1,400, right?
Mm-hmm.
And that'll be 0.4 times 1,400. What's that?
$560.
560. I love it. So now I add those together and I get 1960. Is that cool?
Yeah, but she said she's trying to help.
All right. Let me mute everybody. If everybody could do me a favor, stay muted unless you're saying something. Is anybody not with me? All right. Now I'm going to increase that by 40% again. So 40% of 1960. That becomes 0.4 of me times 1960, and then whatever the hell that is. Is that 776? No, it's 16,784.
Yes, 784.
74. And then I add these together to get the increase right. So I get 2744. Is that right? I think so. Okay. Let me stop for a minute. You guys all with me? Doesn't this suck? Can you imagine doing this? What if I wanted to do it 30 times? Do you want to do this until you get to 30? Do you want to? I don't want to. I really, is everybody sort of with me?
Yes, I'm with you.
I'm
All
with
right.
you.
And again, this is related to compound interest, right? The new amount makes more on top of itself. So here's the shortcut. Shortcut. If I want to take $1,000 and I want to take that and increase it by 40%, and I want to do it 3 times, that is all I have to put into the calculator. That is a shortcut. I take one of these, add 40% of it 3 times. Okay, now the next hurdle is some people got to this point, but then didn't know how to put it in their calculator and got some weird things happening. Is there a difference between that and this? Are those the same?
No.
Hell no, because here I'm cubing this. Here I'm only cubing this. So that was one problem I saw. Somebody in the casino? What's happening? So can you guys put that in the calculator? You already know what we should get. Oh, you're okay, Trisha. It just settled.
Yes, it's the same answer.
Let me know. Let me know right now if you cannot get the same answer. You can even private message me if you feel like you don't want to say it. Right? Let me know right now. Can everybody get that answer? Do you understand what we just did? This work right here is equivalent to this work right here. Isn't that awesome? That's what math does. It says, oh shit, we got an easier way to do this. Because I keep doing the same thing. There's got to be a quicker way to do it. Okay, I like it. What was the other thing? Oh, two other things. Oh, let's do some more of this. Let's really get this down. Let's do some more of this. I'm going to erase all this. You ready? All right. Nobody's yelling at me. So let's see. What if I have $60? I want to increase. You could do it, Jeff. By 7%. I don't want to do it 8 times. Can you write the expression for what you would put in the calculator? Don't say anything. Just take a couple seconds. Oh, I don't know what that means. Did you turn it in, Tricia? Oh, careful. You're missing one thing in there. Well, one thing. So I want to start at 60. If I'm going to increase it by 7, I really want you guys, how much $60 represents 100% of what it is. Are you guys with me? If I get a pie and nobody's eaten any of the pie yet, it's 100% of a pie. You guys all with me? So if I want to increase this by 7%, that means one of them plus 7%. So that's 100% plus 7%. That's why this part is always 1 plus the percentage for an increase. And then how many times am I going to do it? What do I put up here in the power?
8.
8. Let's see, I got all kinds of answers coming at me. One of them sounds way too big.
$103.091117.
103.09, and we stop there because we're humans.
Okay.
This is how you tell me the price of something, right? Yeah. So when you're talking about the price of something, round it to 2 decimal places, or else I'm going to look at you weird when I come to your store. How much does this cost? 4.8372567 cents. Holy crap! Do you need exact change? I don't have half a penny. We're not in England.
Hey, Professor.
Yes.
What did I do wrong when I typed this in? I'll just read it to you. So I put 60 and then parentheses 1 plus 0.7.
Oh,
So when I
you did
put that-
0.7 instead of 0.07.
Oh, that's why. Okay.
You did
Thank
a 70% increase. That explains why
Yeah.
you got such a big number. Yeah.
Okay, thank you.
You are. What if I wanted to decrease something? So what if I had it cost $80 and they're going to discount by 10% and they're going to do that 3 times. So a 10% discount, and then you have a coupon for another 10% off of that. And then they just give you another 10% because they like you, right? Because that always happens.
We have to divide it.
What do you mean divide it? No.
Do you not do a negative?
Yes, that's all. So
exponent?
it's going to be 80 times 1 minus 0.10. Doesn't that make sense? If the increase is 1 plus 0.0 something, right? 1 plus the percent. To increase, to decrease, it's 1 minus the percent. So I take a whole 80 and I subtract 10% of it. And how many times do I do that? 3 times. Do you guys see? So it can handle increase, decrease. Of course it can. Because they both basically are the same work. Just one I'm adding something over and over, and the other one subtracting something over and over.
I have a question.
Yes.
If our power be 4, example, not 3, what will happen?
Oh, if you want to do it 4 times,
Yeah.
then you put a 4 there.
So what about the result? Is effective on the result because we have a negative power. Our power is 4 or 2 is gonna be positive. I think so.
I don't understand.
Our
So
result.
your result's going to be positive always,
Okay.
no matter what. Because what is 1 minus 0.10? What's $1 minus 10 cents?
90 cents.
90 cents. Now, do you have to do this? No, you can just put this whole thing in the calculator, but that's what you're doing. So there's no
Okay,
way you
thank
can multiply positive numbers and come out negative.
I got it. Thank you.
Okay. And then what do you guys get when you do that?
$58.32.
Yes.
Yeah, 58.32. Now. Does everybody get that a little bit better? When will that work? Every time that you have to continuously apply a percentage over and over, every time. So does it work for compound interest in a bank account? Of course. That's why the formula for that looks basically like this. Because it's the same thing. Now, let me see if I could push this last problem. I'm gonna go one step further with this. If I discount by 10% 3 times, is that a 30% discount? No, it isn't. Right? We've talked about that before. What would a 30% discount off $80 amount to? If they had an $80 and they had 30% off, what would that come out to be? Do I have to do all this weird shit? No, I only want to do this once, don't I? So what would that be? In fact, you could still do the shortcut, couldn't you? It'd be 80 times 1 minus 0.3 once. Or you could do it, 30% of 80 and then subtract. That's basically what this is doing. So either way you do it, what do you end up getting? Anybody? Am I frozen or are you guys frozen? No, nobody's frozen.
56.
Yeah, $56. 30% of 80 is 24, 3 times 8. And then you subtract it from 80, you get $56. So is this equivalent to 30% off? No.
No.
I like it. All right. Is that all right? I went a little bit further, but we've talked about this before when they're like, it's 50% off and then another 50% off. So it's basically free. No, it isn't. The bigger this is, the bigger the difference is in the end result. Okay, I love you guys. All right. Now, next thing. Oh, I should have worn my, here we go. Here's a quick public service announcement. You guys ready? You're gonna drive me insane. That is the only thing I can work with is your work. And when I say show your work, I don't mean if you write down 5 times 1 plus 0.02 to the 7th that you have to do that. No, write this down equals, throw it in the calculator, but you got to show me what the hell you're putting in the calculator. You have to, because if you don't get the right answer, how can I help you if I don't know what you did? All right. So this isn't me just being all giving arbitrary. No, I can't do shit for you if I don't know what you're doing. Right? Does that make sense? And anybody who's actually just cheating, just stop, because that's stupid. It's not going to help you at all. Okay. Now, here's the next one. Linear versus exponential. Can somebody tell me, do you guys remember what does linear growth mean? What does that mean? Like, is this linear growth? Is that linear?
Yes.
How do you show me?
Is it because it increases by 3?
Yes, it increases by 3 forever. Somebody just did the first one, said 4 minus 1 is 3, so it's linear. What? You can't just do 1 and tell if it's linear. It's got to be something that goes forever. It's got to increase by the same amount forever. That's linear growth. So how do you determine if it's linear? You subtract these two, get something, and see if they keep adding that. What would the next number be?
13.
Holy shit. Yes, right? Just keep adding 3. I love it. So what about exponential? What is it based on?
Percentages.
Sort of. It's based on multiplication.
Okay.
It's going to be a little bit harder for me. Let's see if I can do this. You can do it, Jeff. Have faith in yourself, buddy. I don't know. You guys can tell me if I'm right. Shit, now I'm in trouble. I think this is right. All right, let's check Jeff's work. This is obviously not linear, correct? Because they don't keep adding this plus 2, plus 240. Oh, shit. That doesn't mean that it's exponential. It could just be neither of them. Couldn't I just make up a bunch of numbers and they don't have to be either one, correct? So linear means you're specifically adding the same amount. Exponential means you're multiplying by the same amount. So what is 12 divided by 10? Just like I did here, 4 minus 1, I added 3. 12 divided by 10, what did I multiply by to get there?
1.2.
1.2. Now, do 12 times 1.2. Do you get this?
Yes.
Now, here's the key. Let's see if Jeff did this right. What is 14.4 times 1.2? Do you get this?
I got 17.28.
Yay, Jeff. Good job, Jeff. So I keep multiplying by the same thing, therefore it's exponential, right? This is the only way you can show me if it's linear or exponential is show me what it is I keep doing. How do you figure out what the next number is?
$17.28 times 1.2.
Yeah, you just keep doing the thing, right? You keep doing the thing. So if in the problem, if it said the next number was 18, is this exponential? No, because I didn't multiply by 1.2 to get this. So that would not be exponential then, right? So some of the answers could be neither, because I don't keep adding the same thing or I don't keep multiplying by the same thing. It doesn't have to be one or the other. Okay, I love it. I love it. How you guys doing out there? This will help some of you make corrections to 1-4. And then finally, here's the last thing I want to talk about right now. This is going to drive me a little crazy. If I said plot -5, 10, 11, -16 on this number line. Let me give myself one more tick mark. Why not? Number one is, if you do this on your own piece of paper, you cannot give yourself more marks than the problem gave you, right? The whole point of this problem is, can you make a scale so that you can find all these things? You have to get used to the scale. So I'm getting too many people tell me this. What's wrong with that? Is there anything wrong with that?
And they're not evenly spaced apart.
Holy shit. Yeah, this is going by ones, and this is actually going by 15, right? 10 minus -5. What? So stop. None of these have to show up on the tick marks. They just have to have a place to go. So maybe what should I go by? Let's see, what if I put 0 here? What steps should I go by to get all these?
Tens.
Yeah, I could go by tens. Let's see, 10, 20. 10 is maybe a little too much, but 10 would work. Do you see how it's a little too much? I didn't have to go that far. Here's -16 then, right? Do you guys see what I'm saying? Now you can find -16. You can find 10. You can find 11. -5, and so forth. You guys understand? You set up your scale first. None of these numbers have to be here, but they all have to be inside of here so you can find them. Does that make sense?
So we don't have to label the point.
Well, I mean, you should. In fact, I think the problem said you would. So that's -16. That would be, where to go? -5. And so, yeah, that definitely makes it easier for me to grade if I know what the point's supposed to be. And I think the problem said to do that. Okay, I love it. So if you want a quick way to make your math teacher or your science teacher cry, it's to pick a scale that makes no sense. The scale has to be consistent, or else you're lying to somebody. So if you get your homework back and you see me saying something like this, you're saying that a step is 12, but then a step here is 4. No. Every step has to be consistent, or else you are lying. Things are not relatively where they're supposed to be. Does that make? And I don't mean lying like you're purposely trying to lie. I'm just saying if somebody looks at your graph, it's not accurate. Wafa, what's up?
Yeah, the problem is with number 3, part B. You know, the numbers is big numbers and big difference, and we can't add any points.
Of course you can. All right. So what if I said to plot these numbers? You just have to pick a good scale. How many tick marks do they give you? 1, 2, 3, 4, 5, 6. All right. You have to pick a good scale. So first thing I want you to realize is, don't I go higher up than lower down? So I could put my 0 down here somewhere, right? Because I want more space to go up higher. Does that make? Do you guys see what I'm saying? So I'm gonna, all right, let's put my 0 right here. And I want to get up to 7,000. So you could actually try something and erase it. So if I go by 1,000, that would be 1,000, 2,000, 3,000. Oh shit, I didn't make it up to there. You guys see what I'm saying? So maybe what should I go by instead? Not 1,000. That doesn't get all.
2,000.
2,000. And again, if you try something and it doesn't work, just erase it, right? If that didn't work, just erase it and make it bigger or smaller. That's fine. Part of a problem is making a mistake first. Why not? If you can identify the mistake, great. And then what would this be?
2000. Negative 2000.
Cool. And now I can find 7,000 is like right there. Negative 700 is like right there. 4,000, oh yeah. And then negative 1,500 is like right in the, is right over there somewhere. There you go. You guys, does that make sense? You don't have to know immediately what the scale. You can try 1,000. You go, oh, that's not big enough. Let me try 2,000. That's fine. Nothing wrong with that. Okay.
Yeah, thank you.
You're welcome. Because that's going to become huge. We're going to graph quite a few things in this class. So we have to know how to get a scale. Sorry, what's up? Everybody good? Oh, my mouse goes to sleep sometimes. I love it. All right, let me see. So I believe we left off. We did probability, right? I want to show you something. Yeah, let me show you this right now, and then we'll do some probability problems. I put something up on the Canvas shell that I want you to do, and this should be interesting. Has anybody ever heard of personality types? For example, I am an ENFP. Does that mean, oh, you know about it?
Yeah, I've done I think I've done these every semester now. I think
Oh, I'm sorry, buddy.
No, I like doing them, so that's always interesting. I find out
Yeah,
something new about myself.
and there are different websites for doing this, but if you've never done this before, it is very interesting. This is, I hope you guys understand. I hope I come off as the kind of person, I do not believe in astrology. Astrology is bullshit. I'm sorry if you believe in it. Believe in it as much as you want to, but it's bullshit. This doesn't consider anything except how you respond to certain situations. And that kind of helps them gauge what your personality. Now, there's a lot of controversy about the end results, but I have to tell you, I've gotten some books specifically about my personality type, and it really helps me get through some stuff, because we all react differently to stress. We all react differently to different things, and they can give you some very specific advice. Anyway, you don't have to get deep into this, but I do want you to take this test. So when you click on it, this is one of my favorite websites for doing this. It'll just start asking you questions, and just do it. And you'll get to the end, you'll get your results. You can read all about them. And this is actually, if you look in the book in section 1.7, they discuss these personality types. And, you know, when you tell me your results, you can tell me, I don't think this is worth anything, and that's fine with me. I don't care. I just want to see what you guys get, and we can use the results in a general way. I can see how many guys are extroverted versus introverted and so forth. I am the most introverted extrovert. I was about to say sign. It's my sign. It's my personality type. All right. So if you've taken it before, take it again. Your personality can actually change over your life, because we all go through shit and things happen to us. So I like that.
And this is in Canvas?
Yeah, the link is in Canvas. It's in the Unit 3. I'm sorry. It's in the Unit 1 module. Let me show you again. Let me become a student so you see what it looks like from a student perspective. So, I mean, here's the quiz, here's the Unit 0 stuff, and here's Unit 1. Remember the human bingo thing? All right, and then if you go down, there's the prefixes we talked about with mega and kilo and all that kind of stuff. And then here's the personality type. It's an actual assignment. Let me make sure you guys understand that. and is due tomorrow night. It shouldn't take too long. It's better if you do it quickly and just give your immediate first reaction to the question. And I'm really sorry if you're not interested at all in it, but I'm a math teacher, so I'm used to assigning things that people aren't interested in. So just do it. Hopefully it's interesting. We'll find out. All right. Any questions on that? Ha ha ha. Okay. How do I get this to stop? Okay, there we go. So last time we discussed probability, and I want to talk about a couple things that might have fallen through the cracks with our discussion. First thing I want to say is something that on first glance seems very straightforward and simple. If there is a, all right, you get it. So if there is a 10% chance of rain, right? So the probability it's going to rain is 10%. What's the probability it won't rain?
%90.
Isn't that crazy? Right? Of course it is, because when you add up all the possibilities, it has to make 100%. So if part of it is 10%, the rest of it must be 90%. Somebody could say, where's snow? Snow is not rain, so it's here, right? So this holds everything, either rain or not rain. There's no other option. Don't come at me with, well, the universe could not exist. Shut up. All right, now, that's one thing. That's one thing. That's how opposite probabilities interact with each other. One is 100% minus the other one. That's how opposite probabilities interact. All right, I'm talking and I'm trying to remember what the other thing I wanted to say. Oh, yeah. Let's say that, so 11% of Americans are left-handed. I can't remember if I asked you this before. There's 26 people in here right now. How many do you expect to be left-handed? If there's 26 people in America, right, in this group, and 11% of Americans are left-handed, how many do I expect to be left-handed out of 26 people? What do you guys think?
3.
Tell me what you do. Tell me what you're doing.
0.11 times 26.
So 11% of 26. If I know the percentage of everybody that is something, and they give me a group, how many do I expect to be that thing is the percentage of the group size. I expect 11% of any group of Americans to be left-handed. So yeah, if you do this, it comes out to be what exactly? 2.82? 2.86?
Yes, it's 2.86.
So we can round it up to 3. Now, can you guys indicate to me somehow, any left-handed people in here right now? Can you tell
Yeah,
me?
I'm left-handed.
There's 1,
I'm left-handed.
2. Anybody else left-handed? No? Okay. We got 2. All right. So I'd expect about 3, and we got about 2. All right. There you go. So the expectation, why doesn't it have to be met? Would it be impossible for there to be 7 left-handed people in here? Would that be impossible?
No.
No, of
No.
course not. Because the 11% is for everybody's. So, but how many do you expect from any subgroup would be 11%? That's how many you expect. How many could there be Any number.
It
Well,
would
what's
be
your
like
best
a
guess?
it'd
Sorry.
be like a random sample, right?
Yes, I love it. And we're going to talk more about statistics later this semester, but a random sample would represent the population. So therefore, it should roughly hold to the percentage. But I could happen to randomly pick a bunch of left-handed people. So I get a lot more left-handers in a group. All right, hopefully you guys are with me. The important thing here is there's a problem that sounds just like this in the homework. They give you a percentage. They tell you an amount of people, and they say how many are expected to do this. Well, this is how you do it. That percentage of the group of people. Now, I will tell you this. There's one problem that hopefully makes us feel bad about the number of women who are currently in Congress. That number has gone up. I think it's 100. In the book, it says 104. I think it's currently 133, if I remember correctly, which is still way below what accurate representation would be. Don't even get me started on counting minorities and their representation in Congress. Anyway, that's discussion for a different class. All right. So let me see. I got to remember now. There were, I think I pretty much just covered the problems in section 1.6 homework that are a little weird. The rest of them need to be pretty straightforward. So the worst thing you can do in this homework is to overthink it. There's a good problem, number 7, that might give people some trouble. Number 7 basically says, what are your chances of passing this class? So what do you base that on? Whatever you want to. How do you answer this question? Tell me the answer, tell me how you got it, and then tell me if the answer can change. Can the probability that you pass a math class change?
Yes.
Of course it can, right? If you haven't been doing the homework and then suddenly you start doing the homework, then you're probably going to do better, right? For example. All right. So, like I said, I think the biggest mistake people make is they overthink some of these things. But there are a couple of these that are a little more detailed that you have to be careful about. I basically went over the idea behind them up here. Okay, so the actual last thing we did, now we're sort of caught up to where we are, was scientific notation. Remember that? Good old scientific notation. And I want to check to see in the homework if they have, get out of here. Yeah, okay. So this homework gets really interesting. All right, so let's try some of this stuff out. Blah, 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 blah. Oh, good Lord. All right. Let me see, maybe I can make some good problems. These are crazy. Yeah, I'll make some good problems. Ushima. Okay, so get out of there. Let me stop sharing. First thing is, let's remember what scientific notation is. Ooh. All right. Okay. So scientific notation, SciNot. How do you convert? Real quick, this should, guys. I think you guys should remember how to do this. How do you make that into scientific notation? decimal is
So
here. Where
move the
should it?
You would move the decimal between the 7 and the 6.
Good. Move it so there's one digit in front of it. 1, 2, 3, 4, 5. Okay. What does that mean? 7.6.
And it would be to the negative.
Yeah.
10 to the negative 1, 2,
Minus
3,
6.
4, 5.
Minus 5. Because I only have to move the decimal 1, 2, 3, 4, 5. That's where I want to stop right there. You always move the decimal until there's a single digit in front of it. Why is this in negative power? Oh, I hurt my finger.
Because it's a small number.
Good, because it's a small number. I love it. I love it. And then a little more technically, because if it was positive, I would be multiplying by 10 5 times, and that would get big. If I put negative, that's actually on the bottom. I'm dividing by 10 5 times. That's why it gets small. Remember, negative powers mean flip. Okay, okay. So then what about this, of course?
You would move the decimal between the 3 and the 1.
3, 6, 9, 10, 11. So it'd be 3.14.
Times 10 to the 11th.
And I really want you to understand, all this really says is multiply 3.14 by 10 11 times. So of course, if I multiply by 10 11 times, every time I multiply by 10, it moves it over. So scientific notation is nothing special. It's just a little computation problem that works back out to this number. All right, maybe. Is that Bill Nye? It is Bill Nye. I like it. All right.
And this is for 1.6, yeah?
Yeah, this is 1.6. No, 1.7. Sorry. 1.6 was probability. 1.7, I believe, is scientific notation. Now, here's the next level of this, everybody. Always another level. How would I do this? Oh, shit. To help us out, how would I do this problem here? Four x to the fifth times 2x to the third. How would I do that problem? What do I get for the number?
Times each other.
8.
8.
And
And how
add
many
the
x
power.
do I have? Sorry?
Mhm.
Good. So how do I do this? The same way. 4 times 2 is 8 times 10 to the, what happens here? When I put these,
You subtract the 11 from the 18.
good. 18 minus 11,
Would be 7.
done. 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 So the way this works is I collect all the x's and then the numbers I multiply. Here I collect all the 10s and the numbers I multiply. No problem. Now, let's make that harder. Yeah. Why not, Jeff? All right. What about this here? Oh, shit. So It works the same way, except, for example, what is 3.6 divided by 3? What's 36 divided by 3?
12.
So then you put the decimal back in. So 1.2. Yes, that's beautiful. Ignore the decimal and then put it back in. Woohoo! But what do I do here? Do I add these powers?
You divide the powers.
No.
No, subtract the powers.
Yes. Here I didn't multiply the powers, did I? I added them. So when I multiply things with powers, I add the powers. When I divide things with powers, I subtract the power. So watch what I can do for myself. 10 to the negative 4 minus negative 15. Subtract that power minus that power. Oh, shit. So when you divide things with powers, subtract the powers. When you multiply things with powers, add the powers. We know these.
So it would be a positive 11.
Look at that. Careful. No, I'm sorry. You're right. I forgot it was negative. So negative 4 plus 15, positive 11. I love it. So I want you to realize, if this was not written in scientific notation, look how disgusting this problem would look. This would be 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jeff, you could do it, 10. And then 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Doesn't that look disgusting? Whereas here, if I write it like this, I can focus on what's important. Okay, maybe. Maybe. All right, we'll see. So that, I will tell you this ahead of time. That section 1.7 homework does get a little interesting. Okay, so we'll see how that goes. So last thing I want to talk about today is just to look ahead to this. We're going to talk about this tomorrow. Hopefully most of you guys get that personality thing done today, tonight, sometime. That would be great. But just to show you this, oh, where'd you guys go? There you are. So here's where they talk about extrovert versus introvert, sensing versus intuitive, thinking versus feeling, judging versus perceiving. So I am an ENFP. And we are a strange bunch. But it is, again, I'm not doing this because I 100% believe this determines everything. No, the whole point of this is not, for example, people that believe in astrology, they'll make excuses for themselves. Well, I'm a Gemini, so of course I'm going to do whatever the hell. I don't know. All right, that's extra special bullshit, right? The whole point of this is not, well, you know, I'm an ENFP, so of course I'm going to do. No. It's understand yourself a little bit better, so you know why you do certain things, right? So we'll see what you think about the results. I don't think I showed you. Oh yeah, and we're gonna now. Part of this is going to be the personality type, but then we're going to get into these things. Do you guys know what? Well, obviously, if I say, "Do you know what this is called?" It says it right there. Have you guys ever worked with Venn diagrams before? Anybody?
Yes.
No,
for-
sir.
Some of you guys, have you ever seen something that? Well, this is not the best. Let me see if they show you a better one. Yeah, blah, barf, 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 barf. There we go. Now we're talking. Let's look at this thing. This is the last thing we'll do today. We'll let us out of here early. Let me see if you guys can understand. So they've created a diagram for 400 entrees at 75 cafeterias on campuses. What does the 142 represent? The meals that were what? What do you guys think? What does this circle right here represent? This circle right here, what does it represent?
Less than 12 gram fat.
Yes. So these are the foods that had less than 12 grams of fat. What's in this circle here?
Less than 350
Good.
calories.
So they're the foods that had less than 350 calories. So what does that 142 mean?
I think mix.
Sorry again?
Mix in the middle. Or
In the middle. But can somebody tell me anything about these foods, these 142 foods? What's true about them?
That they're less than 12 grams of fat and less than 300.
And I love it. They're in both circles. So they match this and they match this. Right? So they probably have very little taste. I'm joking. Maybe not. Maybe they taste okay. Can somebody tell me how many total foods they looked at that had less than 350 calories?
Uh,
142 plus 48.
Yeah. So 190, right? 190. Okay. Do you guys start to see how to read this kind of chart? What is up with these 140? What are these? What are these 140 meals doing out here? Do they match either of these descriptions?
No.
No,
So therefore, they're the meals that had.
no.
Do they have less than 12 grams of fat? No. So therefore, they have at least 12 grams of fat. Do they have less than 350 calories? No, they have at least 350 calories. And these are the ones that Jeff would go for. Hello. Give it to me. Yeah. Okay. Sorry. By the way, I love Mexican food. And I went to a Mexican restaurant once and it had a low calorie section. And the low calorie section was like 900 calories, 1,000 calories. And I'm like, oh my God, don't even tell me how many calories are the thing I'm actually going to get. All right, sorry. Just a quick little note. All right. That's enough for today, I think. You guys all right with that? Is that enough for today? We're doing pretty good. We're right on track, but I wanted today to go back over a few things because I graded a few more 1-4s and I got a little concerned. Anyway, in general, show your work. Remember, turning in homework late is not the end. It's nowhere near the end of the world. It'll only hurt you if you turn a lot in late or if you turn something in very late. So if you need a little more time to finish up, do it. There are people turning stuff in with like 4 or 5 problems completely blank just to get it turned in on time. That doesn't make any sense. It really doesn't. Now, some of you guys are going to hear that and you're going to not do homework for the next few weeks. That's nowhere near what I just said, right? But don't be so down to the minute that you're driving yourself insane and staying up late because it's 11:59 p.m. Go to bed, finish it up the next morning. That's fine, right? It's just if you turn a lot in late or turn something in very late. All right, hopefully you guys understand. Okay. All right, I think that's enough. Let me know if you need to hang out, if you have any questions. Otherwise, I'll see you tomorrow. Yes. Yes. Are you good?
Thank you so much, Professor. Have a nice day. See you
Take
tomorrow.
care, man. Podcast man.
Professor, on 1-4, it kept saying that I needed to show my work, but I turned in an extra paper. It was paper number 3.
All right.
All of my work for, what was that, 7 through 11, because I had to ask you about it. And you were like, yeah, you have to show your work. Anyways, you didn't even write on that page, but you circled all of those problems saying that I needed to show my work.
Oh, I see.
Because I dropped into your office hour and I was like, what do you mean show your work? And you're like, yeah, you have to kind of show how you got there.
All right, I see it. You're good. Let me see. Is that the only issue I had? Let me see. Was the show?
No, there was another issue.
No, you're fine. Yeah, that one little thing is no big deal. I'll make this complete now. Just next to the problem, say work shown on last page or something.
Okay, I
really prefer work to be shown right where the answer is given, all together. But if you do it that way, you just put a little note, work shown on last page or something like that. Yeah.
Okay, because I had it done and I was gonna turn it in, and I was like, I better ask.
Yeah, you're fine. Yeah, I just didn't even register that last page to me. I don't think for some reason. So it's up. I updated it now. You're good. How's everybody else? You guys okay out there? Are you guys actually there? Are these all the people that? There we go. Here's somebody.
Sorry, I have a question for the Venn diagram you just showed. I'm kind of confused on how you went over it.
Okay, let me see where to go. All right, so do you agree that these 70 definitely have less than 12 grams of fat? Because that's what this circle means. Right? Everything in this circle must match this description. Everything in this circle must match this description. So there are 48 things that have less than 350 calories.
Okay.
But don't have less than 12 grams of fat because they're in this circle, but not in this circle.
Okay.
So if you're in this circle, you have this. If you're not in this circle, you don't have this.
Okay.
Cool. And again, we're going to do a lot more work with those. That's basically what tomorrow's class is going to all be about, is reading Venn diagrams and then constructing them ourselves.
Okay. And then, so the 142 is them together?
Yeah. Well, 142, these are the meals that met this requirement and this requirement because they're in both circles.
Oh, okay. Okay. I get it now.
Yeah. So we also call this the intersection, which makes sense. It's the and. Yeah.
Okay. Okay. Thank you.
You're welcome. How's everybody else? All right. Maybe everybody else are the people that logged in and went to bed. I'm going to head out. I don't see any questions. All right. I'll see you tomorrow.
Thank you, Professor.
Certainly. I don't know. Maybe they aren't there. All right. All right. Well.